What's the difference between similar and congruent shapes? Well, first off, congruent shapes, they are exactly the same size. And there's two very significant and very special properties when they're the same size that makes it easy to see. First off, all the corresponding angles are congruent, okay? So let's take a look at this real quick right here. So everybody see that blue angle? It matches up to this top blue angle. So 60 here, and it's also 60 there. Now, this one over here, it's an equilateral triangle, but I really don't care if this angle right here in green is the same as in blue. What I care about is this bottom right angle of the triangle is the same as this one over here. That's what we care about. The corresponding angles are the same. So let's see here. If I pull in a yellow marker here, there we go. This left angle is 60, and that corresponds to the left angle of that one. So all the corresponding angles are congruent to each other. Blue to blue, green to green, yellow to yellow. Now the other thing is that the corresponding sides are congruent. So let me just get a purple one here. You'll see that it is 4 inches on the left side of this triangle. Well, guess what is 4 inches on the left side of this triangle? The same. Okay. Same thing on all sides. All corresponding sides are congruent. And it's easier to see on the corresponding sides when we look at this black triangle. They're copies of each other, so they absolutely have corresponding angles that are the same. Take a look at this left side of the rectangle. It's 4 inches from here to here. Well, it's 4 inches from here to here. The 12 inches running on the bottom of it, same as 12 inches running on this same here. So corresponding sides and corresponding angles both have to be present to consider it congruent. When you look at similar shapes, though, hey, guess what? All the corresponding angles are congruent again. So in other words, when I take a look at this top one right here, 128, it matches up to X down there at 128. When I take a look at 52 degrees right here in the top right corner, there's 52 right there. It's the same with the other angles too. You know, the corresponding angles are congruent. Great. That's fantastic. But for it to be similar, we have to have the sides that are called proportional. And hey, look, take a look at this right here. AB is on the left side of that top on the big parallelogram, okay? On the small parallelogram, the corresponding side is WX right here. So it's 6 to 3, okay? 6 to 3. So we've got big on top and we've got the small size on bottom. And so now if we come through and we're like, hey, what's the size of BC? Well, the size of BC is 10. And again, it's on the big. These two numbers, 6 and 10, they're from the big shape up here, the big parallelogram. The small one down here, we're going to put that 5 on the bottom because the 3 and 5 are there. And do you remember do you remember cross multiplying? Hey, this equals 30 and 3 times 10 equals 30. That means that these two ratios are the same. 6 divided by 3 is the same as 10 divided by 5. Or another way of looking at it is, hey, once we go and simplify these, what's 6 divided by 3? 2. What's 10 divided by 5? 2. So we'd say that, hey, these sides, they're proportional to each other because we can always simplify them down to be the matching value. So an interesting way to prove whether or not similar shapes are similar is not, hey, look, I mean, we know that this blue triangle is smaller than the green triangle, but the way to prove it is make sure that all the angles, the corresponding angles, are the same. So let's take a look at this one. We have a transversal line crossing across lines A and B that are parallel. So this angle right here is an alternate interior angle to this one, and that means that the red angles are congruent. Well, same thing's happening right here with this line that's slicing through the parallel lines. We got another transversal, so this is an alternate interior angle blue to this angle right here. So they are the same size. And then the last thing, I always save this for last right here, we'll put it in yellow. These are vertical angles, so they are congruent to each other. So all three angles of both triangles correspond to each other as far as having the exact size angles, so they are indeed similar. Okay. Very last thing that I wanted to show you, we're starting to run out of time here. Basically, let's go ahead and group this together so I can spin it around. Do you see where 10 and 10 right here, it's shaped like a right triangle? If we spin this around, See where 5's on the bottom and right here on the side? Well, now that lets us be able to um, find out if it is a similar shape. And right here, there we go. That's a big clue. When you can stick it inside of the bigger shape and it kind of matches up on the sides, that works out. But what happens is that we've got to set up a proportion with 3 numbers that we know about to go find the fourth that we don't know about. So here we go. Here's this one. We want to know that. These two sides are the same, so that's very, very similar to these. Well, let me backtrack here. We know we need to find how long that missing side is on triangle XYZ. Um, and let me just go ahead and kind of color in that side. We need to find the length of this side. So in order to set up a proportion, you know, this is the small one. This is the big one. Generally, I always put the big on top, small on bottom. Okay. And so since I have the small, we'll go ahead and put that right there. Instead of a question mark, we'll go ahead and call it X, okay, or whatever variable that you want. And we need to find which side this matches up with. This is 5 and that's 5. And these two are the same, 10 and 10. So it would make sense that 12 is the corresponding sides there. So we'll put that one on top. Now all we have to do is find 2 more corresponding sides that we can have the numbers for both of them. Remember, big on top, small on bottom. So let's go to blue here. That would correspond with BC right here. That would be 10. 10 on top, 5 on bottom. So to rewrite our proportion, it'd be 10 over 5 equals 12 over x, and then we can cross multiply. And there you have it. The missing length for side xz is 6.